Hello everyone, my name is Pukbola Oladotun. I work at Nigerian Center for Disease Control, National Reference Laboratory. I lead the bacteriology team in the National Reference Laboratory. I'm a medical laboratory scientist. Thank you. I will be presenting on quality management and supply chain management in a bacteriological laboratory. And the following are the outlines that will guide us in this presentation. The first one is the quality management system, quality manual and SOPs, and how to use them. External Quality Assurance Program, EQA, retesting by National Reference Laboratory, both at Abuja and in Ibadan. And how do we store our isolate? Media preparation and quality control, overview of inventory management. This slide is telling us about quality management, quality assurance, and quality control. Quality management encompasses all activities in the laboratory to be able to get an accurate, reliable, and timely result in our laboratory. It encompasses all activities that is done in the laboratory pertaining to quality. Quality assurance is also part of quality management, in which it deals with the pre-analytical, analytical, and post-analytical of the testing. Quality control is part of quality assurance, which monitors the analytical phase of our testing to be able to detect error in whatever we are doing pertaining to testing, maybe due to system error, operational error, and environmental error. The following are 12 essential quality management systems, which is applicable to all testing in a laboratory. That is, we have organization, personnel, equipment, purchasing and inventory, process control, information management, document and records, occurrence management, assessment, process improvement, customer service, facility, and safety. In the 12 quality essentials, all are very important for us to be able to have our results accurately, reliably, and also in a timely manner. Quality assurance has been defined by WHO as the total process where the quality of laboratory reports can be guaranteed. This quality assurance relates to our pre-test, testing, and also post-testing. We have to be very sure that whatever we are doing at these three phases, our quality assurance is in place to be able to monitor error. It can be summarized as right result at the right time on the right specimen from the right patient, with the result interpretation based on correct reference data at the right price. Quality control, as earlier said, could either be external or internal. It covers part of quality assurance, which control errors in the performance of tests and verification of best results. Tests must be practical, it must be achievable and avoidable for us to be able to control our testing properly. External quality assessment is external evaluation of laboratory performance on set of samples sent to a number of laboratories. This is also to monitor our testing processes in our lab, to be able to know whether we are giving accurate results, reliable results, and in a timely manner, to be able to compare what we have done in our own laboratory and also get results from the external, to be able to know we are on the right track. Standard operating procedures, which is also called SOPs, have the following objectives that is backing it for use. Is to improve and maintain the quality of laboratory service, to provide laboratory staff with written instructions on how to perform their tests, and also to avoid shortcuts, to use in the training, to prepare list of inventory of reagents and equipment, also to provide safe laboratory practice. SOP is a way to guide us in whatever we are doing to be able to achieve a reliable and accurate result. These processes comprises of these SOPs: training, consultation, review, audit. All these are also part of a quality management system. Quality manual, a document describing the quality management system of an organization, and it has to be in line with ISO 15189. A quality manual must communicate information to the team and serves as a framework or roadmap for meeting quality management system requirements. It demonstrates management commitment to quality. Key points to note on quality manual: it must be only one official version. Never done, always being improved. You improve on it continually. Read and accepted by everyone. Everyone in the department or in the organization need to read and accept it before it can be used. Use the best adapted language. Standard operating procedure describe the procedures to be performed in the clinic and laboratory in order to ensure uniformity, accuracy, and reliability in all of the activities performed in the diagnostic pathway. Its aim is to standardize blood, CSF, cerebrospinal fluid, and urine sampling and processing, procedure for pathogen identification and resistance characterization. It also provides guidance to health workers, reduce systematic errors, and guarantee staff and patient safety. The objective of SOP is to improve and maintain the quality of laboratory services, to provide laboratory staff with written instructions on how to perform tests, to avoid shortcuts, to prepare list of inventory of reagents that is in stock and also the equipment, to provide safe laboratory practice. A good SOP provides detailed, clear, and concise direction for testing techniques. It is easily understood by new personnel. It should be reviewed and approved by management. It's updated on a regular basis. This shows the example of how an SOP should be. This is the format. It should be a computerized procedure. It should be standardized, that is, having a header, fashion, chapter, and reference. There should be an author, reader, validator, recipient, fashion date, application date, and typical outline. Updating and storage of different fashion is easy if we follow all these steps. This is a good example for each and everyone to adapt to be able to write our SOPs. Job 8 is a shortened version of SOPs, handwritten or printed. It should be in a visible location at testing site. Useful tool to assure all testing steps are correctly performed. That is, on my left hand side is a handwritten one which is clear and legible, and on my right hand side is the testing scientist which placed the SOP by the bench that it can follow easily to be able to perform the testing and have accurate, reliable results. Specific contributory factors to quality in microbiology. The following are contributory factors to quality in our microbiology laboratory. That is technical competence and experience. The scientist must be competent and have experience on what he or she is doing. Incubation conditions have to be maintained. Media and reagents need to be prepared correctly. Homogenization of sample, Reading and interpretation of results. Inoculation of media should be to an appropriate media so as to get our result, and our dilutions too should be accurate. Examples of quality assurance across the diagnostic pathway. We have pre-analytical, we have analytical, and we have post-analytical. In pre-analytical, we have to follow this procedure: aseptic sampling, use of request form, collection and transport of specimen, checking of specimen and request form. This is done in order to be able to be sure that truly what we are doing is correct, truly what the sample we have received is the right one, in order to move to analytical stage. We need to check the documentation properly and compare with the sample we have received. And also at analytical stage, we need to detail everything very well. The procedure for processing specimen. We have to use aseptic techniques and safe handling of infectious material. We need to include our quality control and safe working processes. We put them in place to be able to achieve accurate results. At the post-analytical stage, we report and verify our test results. Any preliminary report must be followed by a full written report. All reports must be checked for corrections and clarified and signed by head of the department, control of equipment. External quality assessment. This diagram is telling us about the process we need to follow in order to have our accurate, reliable, and timely results. That is, prepare your sample very well, examine the samples at the analytical stage. After examination, you report your results, and it goes to analyzing of the results also, and you prepare your results and it goes for evaluation. Usual format of proficiency testing program is a set of samples to each participant together with a set of instructions and any necessary background information. Participants carry out the requested analysis in their normal manner and submit their results to provider. Providers analyze and generate a report to give to each participant to allow them to compare their performance with the other participants. Performance of individual laboratories will only be known by the particular laboratory and to a limited number of management personnel. The benefit of external quality assurance proficiency testing is to provide staff with an insight into their laboratory performance, provide a comparison of performance with other laboratories nationally and internationally, improve the standard of examination, identify areas where there may be problems, demonstrate to clinicians, other stakeholders, and accreditation bodies that there is a commitment to quality. It also benefits by educating the staff, providing a better understanding of the impact of incorrect results. Relationship between internal and external system. We have relationship between them. The intra-laboratory or internal repeatability. Repeatability is a form of getting tests done within the same facility, the same sample method, same lab, same analyst, same equipment, same environmental condition, and shorter period of time. This one will make us to know whether truly we are doing well or not. For interlaboratory or external reproducibility, we send sample outside to be able to compare what the results they will generate will be the same with what we have been generating in our own lab, but we will have the same method, the same sample, but different labs, different analysts, different equipment, different environmental conditions, but it takes longer period of time because it needs to travel far before the result comes back to us. International Organization for Standardization, that is ISO. ISO 17025 is a general requirement for the competence of testing and calibration laboratories, whereas ISO 15189 is for medical laboratories, that is people who are performing the testing in a medical lab, and particular requirement for quality and competence. Formulate measurable objectives in terms of results. What must be achieved in the results? What are the criteria we need to follow? Time, that is when. Responsibility, by whom. Media preparation. Media preparation in medical microbiology laboratory. This is carried out in a media room separated from the main laboratory. It requires sterile glassware prepared by autoclaving and sterile plasticware. A supply of dehydrated, ready-to-use media and supplements, and fresh blood purchased from commercial suppliers. Materials are weighed in a fume hood to prevent exposure to dust and then dissolved in water to make a suspension. This is then autoclaved in the media room. Media preparation continued. Plates are poured in a simple plastic hood to protect them from atmospheric contamination. The hood is maintained free from bacteria by an ultraviolet light switched on when not in use. We pour the plates, are allowed to cool, and then dried in the incubator at 37 degrees Celsius and stored in a fridge at 2 to 8 degrees Celsius until required. We can see the example in the picture shown to us. In order to quality control our media that we have prepared, we do growth performance. We do this by testing the growth support, properties of the media. This is done by inoculating the medium with appropriate stock cultures and of fresh isolate. We use a standard inoculation procedure and examine the quantitative and qualitative results obtained. If testing new lots or batches of media, we have to inoculate old and the new lot in one test. We compare the performance of the two lots side by side. The following are the culture media we use in laboratory, microbiology laboratory, and these are the control strains that is applicable to each media and the expected outcome. For McConkey, we have E. coli ATCC 29522, and we are expected to see a lactose fermentation. On blood agar, we have B. hemolytic streptococcus species. Evidence of B. hemolysis is expected as the outcome. Chocolate agar, Streptococcus pneumonia ATCC 49619 is expected to see alpha hemolysis. For nutrient agar, the control strain to use for growth performance is Pseudomonas aeruginosa ATCC 27853. Also, we are expected to see greenish pigmentation. For Bulla intin agar, E. coli ATCC 25922 for AST, it must be within range zone of inhibition. Why quality control culture media? We do the quality control in order to fulfill a regulatory expectation. Also variations within manufacturing, that is lot to lot, including sterilization, variation within the quality of raw materials, transport condition, whereby maybe during transportation the media must be affected by the condition of transport. Also storage condition may affect our media. That's why we do quality control of culture media. Different applications of media in different environments. The physical parameter, that is solid media, excessive bubbles or pit, unequal filling of plate, cracked medium in plate, gel strength and friction or crystallization. Liquid media, Clarity of broth. All media, pH value of the medium, that is pre and post sterilization. We have to measure the pH of this media. Growth characteristics. Quality control of culture media, that is manufacturer to assess quality of manufacture, user to assess, described as media quality control, growth promotion, and nutritive properties. Quality control continued. When to perform media quality control. The following are the time to perform media control. When incoming raw material, that is base media powder, we are receiving it in our laboratory, we need to perform media quality control. After manufacture, after additional treatment such as irradiation, to assess delivery, heat shock and cold shock, to assess changes to storage conditions, e.g. cold store or ambient. As part of shelf life studies, the expiry time. Storage conditions are important. Routine storage. When and how expiry time is assessed. Different storage conditions affect drying out due to different humidity levels, which can affect the water activity of solid media. Chemo-oxidation due to physical factors like heat. Photo-oxidation from sunlight. Sources of microorganism, type, culture, or reference strains. It must be from recognized culture collection, that is American Type Culture Collection or NTCC. The advantages are for interlaboratory consistency. Pure cultures, most grow readily, recognized by regulators. It is very important for us to use a control strains that is being recognized. Can be costly and difficult to maintain, but we have to abide with it so that we have an accurate result. Test on media sterility is part of quality control. That is, a small number of uninoculated items or media are incubated alongside the test items for the same period of time. That is, after we have produced our media, we need to do sterility testing by picking a batch or different batch of the media and inoculate alongside or incubate alongside with the test, so that we'll be able to check whether it's sterile, what we have prepared is sterile or not, and there should be no growth in this item. It's often part of a successful test release. How to store all isolate from blood cultures. Documentation of isolate and result. Transfer of isolates to Ibadan. Shipment conditions and timing. Bacteria that should be sent to NRL as soon as possible, only for blood culture. The following are bacteria that should be sent to the National Reference Laboratory as soon as possible, only for blood culture. When we detect or identify the following organism, we need to send them to National Reference Laboratory. Staph aureus, that is methicillin-resistant Staphylococcus aureus, if vancomycin is considered as therapy. Enterobacterias, that is carbapenem, the third generation cephalosporin. Acinetobacter, carbapenem 2. Streptococcus pneumoniae oxacillin, which is less than 8 mm in the inhibition zone. Neisseria meningitidis, always you have to send this. Fibrocolerae, you can send these too. Test report content in terms of ISO 15189. Test identification, that is primary sample type. Laboratory identification results in SI unit. Patient unique identification and location. Biological reference intervals. Name and address of requester. Interpretative comment. Date and time of collection. Date and time of release of results. The person authorizing the release with signature when possible. Note if reporting a corrected result. All these are supposed to be in our test report template. We should please take note for us when we are designing our test report content. All this needs to be on it. Procurement and supply chain management. When should new batches of supply be requested? How to document stock and inventory system. Our inventory management, proper maintenance of adequate stock to ensure uninterrupted service. Support quality laboratory testing. Materials are available when needed. Avoid wasting and the use of expired kits and material. A good inventory management includes knowing and doing. That is, we should know when and what to do per time. We should always make sure that our stocks are up to date. We should use our FIFO, first in, first out, to be able to avoid uninterrupted service. What do we need to know? That is, what to order. How much do we need to order? And when are we supposed to order? What to order? Where to store? You should have a very special store to be able to store whatever we might have ordered. What do we need to do? The following are what we need to do. We need to make sure we do our stock counting always and record keeping, placing orders, inspecting deliveries, and ensuring proper storage. The key messages to inventory management are: we should maintain an adequate inventory at all times to ensure uninterrupted service. We should reorder before running out of materials and kits. Do not order beyond your storage capacity. Do not order beyond what you can exhaust before expiry. All items in the inventory must be properly recorded. Always inspect new shipments before accepting. This is very important in order for us not to receive an expired product, and at the end of the day we will not be able to use the materials or the kit. Thank you for listening.